Hi, this is your math coach, Howie Tutman, presenting What Math Should My First Grader Know? I've recorded videos in the four domains or groupings of standards in math for first grade. This video is the second of 10 videos in the Operations and Algebraic Thinking grouping. The video is about solving subtraction word problems and determining the unknown number in an equation. This is the second of a two-part video. If you have any questions or comments, please email me at hrtutman@gmail.com. The complete text of the two standards that this video is based upon follows at the end of the video. This video will continue with the same two standards as the previous video, but where the last one emphasized addition equations, this video will concentrate on subtraction. So, here are some different types of subtraction equations that our first grader may see. So this first equation, 10 minus 6 is equal to some unknown, or the unknown is equal to 10 minus 6. This is probably the more traditional way that our first graders have seen subtraction problems. And once again, if they are comfortable with their fact families and they know how to be making a 10, they might be able to recognize that they know the fact family of 6 plus 4 is equal to 10. So therefore 10 minus 6 is equal to 4. Same with this equation, they would go through the same process to determine that the left side of the equation should be equal to 4 since the right side of the equation is equal to 4. And once again, for our students that may not have complete command of their fact families and of their making 10 strategies, they may have to say to themselves, 10, I need to take away 6. They may need to be using counters or a number line, or they may be able to be using just some dots. So if I'm at 10 and I need to take away 6, I'm going to be subtracting 6. So let me put 6 dots here because I'm going to be subtracting these 6 from the 10 that I already have. So if I start with 10 and I subtract these 6 dots, it's going to be 9, 8, 7, 6, 5, 4. So their answer will also match the answer of 4. It's not as efficient. It's prone to error here in counting the dots or whatever method they might be using, but it's a start. And once students get command of making 10 and of their fact families, they'll be able to solve the problems more quickly, more efficiently, and with less errors. This first subtraction equation could represent three different situation types. The first is one that is probably the one most common to the first graders. In this one here, you'll be taking some amount from a larger amount and trying to find the result or the difference. So in this problem here, 10 cookies were in the cookie jar. So that's what we're starting with, the 10 cookies. And then if I eat 6 of the cookies, I need to take those 6 cookies away from the 10. So 10 minus 6, I'm looking for this result unknown. And when I do the subtraction, 10 minus 6 gives me the answer to how many cookies are in the cookie jar now, and that would be 4. Now, a couple of other type problems that this equation could be representing would be the 10 apart, add-end unknown. Now, in this problem, 10 cookies are on the plate. 6 are chocolate chip cookies. The other cookies are sugar cookies. How many are sugar cookies? Some of our first graders might see this as an addition problem. We have the total of 10 cookies, and then our two add-ins would be the 6 chocolate chip cookies, and then the other add-in would be these sugar cookies that we don't know how many there are. So these students might set this up as an addition problem. 6 plus some amount is equal to 10. But other students might realize in the part total, they can just start with the total, subtract one of the add-ins, and then they will get the other add-in, which is the answer to how many are sugar cookies. And then in this final situation, the compare difference unknown, there are 10 chocolate chip cookies on the plate, and there are 6 sugar cookies on the plate. How many more chocolate chip cookies are there? So this is a comparison problem where we're comparing the 10 chocolate chip cookies to the 6 sugar cookies, and we're looking for the difference. So it would be 10 minus 6 is equal to some amount. Some first graders might set this up as an addition problem where they might say 6 plus some amount is equal to 10. And that some amount would be that same answer of 4. One of the things to look out for in this problem is some children may see the 10 chocolate chip cookies and the 6 sugar cookies, and if they're not reading the problem completely, they may also see this word and they may quickly just add these two together and come up with an answer of 10 plus 6, and that would be equal to 16. That would be the answer to the problem if it said there are 10 chocolate chip cookies and there are 6 sugar cookies. How many cookies are there in all? So students need to make sure to read the problem completely, and in this case here, make sure that they understand the situation. Once they do that, hopefully they realize that it's a comparison problem, and this is one of the ways that they can set it up as a subtraction problem. 10 minus 6 is equal to some difference. Looking at a couple of other equations here, for subtraction, students might see the unknown first. So it might be something like the unknown minus 6 is equal to 4, or maybe showing 4 on the left side, 4 is equal to some unknown minus 6. Once again, if students are familiar with the fact families, they may be able to come up with 10 right away because they know that 4 plus 6 is equal to 10. And once again, for our students that may not recognize that right away, they may need to add on 4 to this 6 that they're subtracting because they know that this left side of the equation is supposed to be equal to the same as the right. So something minus 6 needs to be equal to 4. So if they add 4 more on to the 6, they'll come up with their answer. So they're starting at 6, 7, 8, 9, 10. This equation, question mark minus 6 is equal to 4, is probably one of the hardest for our students. So let's give it some context by making a word problem, and then the equation will have some meaning. This equation could represent a situation of a take from, start unknown problem. So this first number would represent our start. Second number would represent the change. And the third number, the one after the equal sign, would represent the result. So the start is something that we don't know. We know that we're subtracting 6 for the change. So since this is a subtraction problem, we know that the result will be less than the start. So here's the word problem. Some cookies were in the cookie jar. That's our start. We don't know how many. I ate 6 of the cookies. So that's the change. That's the action. 6 of the cookies were eaten, and then there were 4 cookies left. So that was the result. Then the question is, how many cookies were in the cookie jar before I ate the cookies? So that is the start unknown. We don't know how many cookies are in the cookie jar. So I have a little drawing and some manipulatives to represent this problem. So here I am, and I've reached in and taken and eaten 6 of the cookies. And then after I ate the cookies, I took a look in the cookie jar and I saw that there were 4 cookies that were left in the cookie jar. But I'm wondering how many cookies were in the cookie jar before I ate the cookies. So this is the picture that I drew to represent the problem. Some amount of cookies were in the cookie jar. I ate 6 and there were 4 left. So now if I want to try to figure out how many cookies were here, well, let's see. I ate these 6, and if I didn't eat these 6 cookies, they would have been in the cookie jar. So there's my 6 cookies that would have started in the cookie jar. And then I'm left with 4 cookies. So these cookies should be in the cookie jar also. So when I move these back into the cookie jar, I can see I have the 6 cookies that I ate plus the 4 cookies that were left in the cookie jar. So the total of the 6 plus the 4, that would give me the answer of how many cookies were in my cookie jar. So if I know my add-ins to 10, 6 plus 4 would be equal to 10. Or if I need to count, I have the 6 that I started with, 7, 8, 9, 10. And here's another way that our first grader can look at this problem. They can be looking at it as a part-part whole or part-part total or total part-part. So the total is how many cookies were in the cookie jar before we ate any. And the 2 parts are the 6 cookies that I ate and the 4 cookies that were left in the cookie jar after the cookies were eaten. So when these 2 parts get added together, 6 plus 4, that will equal the number of cookies that were in the cookie jar before we ate any cookies. So when students are given a word problem, they can use manipulatives or drawings or pictures of the story to help them solve the problem. Problems like this word problem and equation are generally not readily solved by first graders. It takes practice seeing these types of problems, and students will continue working with various types of addition and subtraction problems in first and second grade. And our last equations that we'll look at, 10 minus some quantity is equal to 4, or 4 is equal to 10 minus some quantity. Once again, if our students know their fact families, 4 plus 6 would be equal to 10. Therefore, they know that 10 minus 6 is equal to 4. And once again, for our students that know they need to be subtracting something from 10, but they really don't know what they're going to be needing to subtract, they may count down from 10 to get to 4. So if they're counting down from 10, be 9, 8, 7, 6, 5, 4. And when they look to see how many they've counted down, it would be 1, 2, 3, 4, 5, 6. And that would be their answer. So 10 minus 6 would be equal to 4. So once again, these are some of the types of subtraction equations that our first graders may see when they try to solve for the unknown. So for this last subtraction problem, we can create another word problem using our cookie jar and cookies, and this will be a take from change unknown situation. So in this problem here, our first grader knew how many cookies were in the cookie jar before he started eating any, and he also knew how many were left in the cookie jar after he ate his cookies. But what he's trying to find out is how many cookies did he eat? So here's our problem. There were 10 cookies in the cookie jar. That would be our start. I ate some of the cookies. So that's the action, that's the change, and it's a subtraction problem. And the change will result in a number smaller than our start. So it's start of 10, change unknown, and the result is 4 cookies. So what I'm showing here, just like the last situation, using a part total. The total is 10. That was our start. The change is one of the parts, and that's what we don't know. And the other part is what we're left with. A first grader may know their make 10 strategy and may know that 6 plus 4 is equal to 10. Therefore, 6 is the change. Or they may use a subtraction strategy where they're going to subtract 4 from 10 to get the 6. Or they may count up from 4 until they get to 10 to get their answer of 6. Some first graders may think of solving this word problem using a 10 frame. So they would fill up with tiles each of the frame in the 10 frames to represent the 10 cookies in the cookie jar. And then what they may do is, if they were doing this on paper, maybe take with a pencil and think, okay, well, there were 10 cookies in the cookie jar, and there's only going to be 4 cookies left. So that means that all of these other cookies I'm going to cross out, or maybe I can cross out each individually, or maybe just make one big X through these other cookies so that all I'm left with are these 4 cookies. And then the student can think, okay, how many cookies did I eat? Well, these cookies would be what I ate. So it would be 1, 2, 3, 4, 5, 6. Or if students were using actual manipulatives, instead of crossing out, what they may do is take each of these tiles that are representing our cookies and move them over. And with the actual tiles, they can see that they're leaving 4 cookies in the cookie jar. And how many did they eat? And if they need to count them, they can count them. And if they order these so that they don't miss any at all, they can count them 1, 2, 3, 4, 5, 6. If you're interested, here are the complete 2 standards that this video, solving subtraction word problems and determining the unknown number in an equation, is based upon. Use addition and subtraction within 20 to solve word problems involving situations of adding to, taking from, putting together, taking apart, and comparing, with unknowns in all positions. For example, by using objects, drawings, and equations with a symbol for the unknown number to represent the problem. Determine the unknown number in an addition or subtraction equation relating 3 whole numbers. For example, determine the unknown number that makes the equation true in each of the equations. 8 plus question mark is equal to 11. 5 is equal to question mark minus 3. 6 plus 6 is equal to question mark.